Okay, next I want to talk about adiabatic cooling and heating. And so we talked about how condensation occurs when air is cooled to the dew point, and then it becomes saturated. But one thing we need to kind of back up and talk about is how does air cool down? And air cools down as it moves upward, and it heats up as it moves downward. So as air is rising, the pressure changes, pressure decreases, and the molecules spread out, and it's called the adiabatic cooling. And so as air moves upward, it cools down, cooling the air, bringing it to the dew point and causing condensation. Conversely, as the air is moving downward, it's compressing and heating up. Has the opposite effect. It has a drying effect of the air, because as it heats up, it can hold more moisture and the air becomes drier. Okay, so we've talked about the environmental or normal or average lapse rates before, and this is assuming that the air is not moving. So if you can imagine, if you had a jetpack and a thermometer, if you were to just move through the atmosphere, taking the temperature at different altitudes, it would be about 6.5 degrees cooler for every 1,000 meters or every kilometer. But that's assuming that the air is moving. It's a very constant difference in temperature as you go up through the atmosphere. The environmental lapse rate is the real one. It would be the 6.5 degrees is the average. The real lapse rate would be a little different every day. We've discussed that in the past. However, air, because it's being compressed and uncompressed, it cools differently than the outside environment, and so we use a different lapse rate to describe that. And so a adiabatic lapse rate is about the changes in the moving air. So as air rises, it cools down rapidly. However, when it becomes saturated and condensation occurs, two things get released during condensation. The first one is moisture. However, we need to go back and think about the concept of latent heat, that when water evaporates, it takes away heat from the oceans, but then when it condenses, it gives that moisture back, right? So take the sweat from your body. When it evaporates, it removes heat from your body, but that heat does not disappear. It is kind of contained in the water vapor, and as the water vapor makes its way into the atmosphere, and as it cools, the condensation will occur and will release that heat. So because of that, there are actually two different lapse rates. There is what's called the dry rate. The dry rate is the rapid cooling of the air as it moves up and becomes uncompressed. That's 10 degrees per kilometer, 10 degrees Celsius. However, what happens once you reach the dew point and condensation occurs, that releases heat, and that release of heat will slow down the cooling down to 5 degrees or 6 degrees. And I think in the book it says 6. I'm going to say 5. It's somewhere in between there. It's about half of what's called the dry rate. So that's called the saturated, or sometimes called the wet rate, of 5 degrees per kilometer or per 1,000 meters. And probably the short of it, you need to know that the cooling slows down because of the release of latent heat. Now, when air is moving downward, because it's becoming drier, it always warms at a rate of 10 degrees per kilometer or 1,000 meters. I should note that 1,000 meters and 1 kilometer, they're the same thing, because there's 1,000 meters in each kilometer. So you have air rising from the earth. It's cooling down pretty fast, about 10 degrees per 1,000 meters. And then it cools down to where it reaches the dew point. And where it reaches the dew point, as it keeps going, this is where clouds are going to form. You have condensation that occurs and droplets that are forming into clouds. When that condensation occurs, you have the release of heat. Heat that was absorbed when the water evaporated is now being released during condensation. And that rapid cooling now slows to a slower rate, about half of the earlier rate. So adiabatic lapse rates are about the changes in moving air. So the temperature of the air itself as it moves up or down in the atmosphere rather than the just generic outside environment. So if you imagine just have the thought experiment, you have a bag of air. As you move that air upward using your jetpack, it will cool down at 10 degrees for every 1,000 meters until it reaches the dew point, whatever elevation that is. And when that happens, condensation occurs, the cooling rate will slow down for that air that's moving up. Because condensation involves the release of moisture, but also the release of heat through latent